the quadratic function. Okay, that's what section 2.1 is dealing with. We're dealing with transformations of quadratic functions, and quadratic functions only. What makes it a quadratic? The squared, right? When you have squared involved, then that makes it a quadratic. What kind of shape is it? What's the name of the shape? A parabola. You guys also referred to it as the U, right? Because it looked like a U. All right. So for this particular thing, we're going to deal with it more on a parabola basis. So when you hear me say parabola, I mean quadratic. The first type, just to kind of go through this one more time. If my parent is f of x equals x squared, which we've already dealt with before, what if I say g of x, x minus h? What's that letter doing on the inside?
Which one?
The h, because it's the only one inside.
Replacing a number.
Okay, it's replacing a number, so that number could be positive or negative, okay, but that h is going to be which way? Left or right, depending on if I put a positive or negative number in for h. That h is referred to as, when we put that dot on the bottom, you know, when we have that parabola piece, if you didn't notice this when we had the parents, every parent went through the origin 0, 0, right? When I put h in there, all I'm doing is shifting it to the right or to the left. I am adjusting what they call the vertex. The vertex is the high point or the low point in a parabola. Okay? So if it opens up, like the main parabola does, that's a low point. If it opens down, like the arch in St. Louis, that's a high point. Okay, so that vertex would be a high point in that case. So when you see this one right here, where the h is like that, that's going to adjust it left and right. Is that any different than what we had in chapter 1? No. Now, what if I put a plus k on the outside? Which way does that shift it? Up or down, depending on if I put a number negative or positive in for k. The h and the k is your vertex. That is either going to be the high point or the low point of your parabola. If I don't give you numbers there, you understand them to be 0. So if I graph the parent function should go through the origin, and we did that many times in chapter 1. Now if I put a plus 3 on the outside, we're going to move it up 3. If I put a minus 5 on the inside, you're going to move it right 5. That's not changing from chapter 1 to now. The h and the k do the same thing that we did in chapter 1. Okay? Does everybody remember or okay with those? Because what you're going to do on this particular section, just so that you know what the directions are going to say, it's just going to say, describe what happens and draw the graph. Notice it didn't say parent this time. So you don't have to draw the parent unless you want to. Okay? What if you have a negative on the outside? What does that do? Okay, that's my reflection piece, right? And that's over the x-axis. What if it's a negative on the inside? That goes over the y. So again, this is nothing more than just kind of review of what you did yesterday on your test for chapter 1. Now, on the way that the graph has been shown, or the one that I've been kind of writing now, where I had x minus h, the quantity squared, plus k. Now if I have a negative on the outside, that flips it over the x-axis. Or better yet, here's what happens. Here's the original one that goes up. If you flip it over the x-axis, it goes down. The bridge that I have over there, the Golden Gate Bridge, is an example of what some of the things we do in math apps. That parabola goes up. The arch in St. Louis goes down. The arch in St. Louis, when they made that monument, they flipped it, or they reflected it over the x-axis, and then you had to do whatever they had to do. If they put a parabola like that going up, chances are, unless they really had it sturdy, that thing would have blown over by now. Okay? Huh?
It moves.
It moves? I've never been there.
It's like really high up. And when
I've heard that.
And you move. If it's really windy, it sways back and forth and you can feel it.
Yeah, I've heard that, but I've never been there. Again, one more place that wouldn't mind seeing. Okay? Then, the next part. Vertical or horizontal, stretch or shrink. Okay? When it's multiplied on the inside, the letter that we're going to use for this is not going to be H and K. Now I'm going to throw an A in there, just so that you guys know. Okay? If the A is outside, what way would the A, what would that do if the number's on the outside? Vertical or horizontal? Vertical. So this goes vertical because the A is outside. Again, do you remember when I wrote those rules in chapter 1 where I said if A is greater than 1, why do you think I use the letter A? It's used now. That's why we do that. Okay, they all connect. So again, it's a stretch if A is greater than 1, and it's a shrink if A is between 0 and 1. Now, again, I'm just going to remind you, not even 5 minutes ago, I asked you about all these, and you guys nailed every single one of them. Am I doing anything different than what we did with the lines or with the absolute value? Absolutely not. I'm just using the parabola as the parent all the time. I'm not going to throw the other parents in there. It's only the parabola that we're worried about, or the quadratic. Okay? But the rules are the same. What if the A goes on the inside? Horizontal. Right. So now we're horizontal. Get that out of there like that. And it's a stretch if the number is what? Between 0 and 1. And it's a shrink if what? Greater than 1. What you're going to be responsible for is you're going to be responsible for graphing and describing. And then the next breath, they're going to say, here's the parent, write the rule. This is the same as what you did on your test yesterday. The only thing I'm not going to ask you for is you don't have to draw the parent. Unless you really want to. If you really want to draw the parent, then go ahead. But the parent for every single one of them is going to be a what? Parabola. Okay? It's not going to be the V or the line or the constant. It's just parabola all the time. Okay? So, if you go to page 52 and 53, Chandler, I appreciate you. Would you pick a number from 3 through 12? 6. Number 6 says g of x equals x minus 4, the quantity squared. And on the directions, it says, describe the transformation that took place, then graph the function. Notice the difference in directions from last chapter to this chapter. Last chapter it said, graph the function and its parent, then describe the transformation. I'm just asking you to describe the transformation and draw the new one. So, a minus on the inside does what? It goes right, how far? 4. Awesome. That's the description. Now, as far as me graphing it, what do you guys want me to do? Do you want me to show you the parent again? No. Okay. Again, well, I'm going to anyway on the first one. So here's the parent. Oh man, it started out so good too, and then the one side got a little... Alright? But, now it said, you guys told me to go right 4. So all I'm going to do is pick that thing up, Walk right 4 spaces and then drop it off and it's done. So this is the number that I'm referring to as the vertex. That's the bottom spot. Okay? It's the bottom piece of the bowl. If you think of a parabola like a bowl. So you're going to grab that and move it over 4 spaces to the right and then drop it. So 1, 2, 3, 4. Is the parabola supposed to be the same size? As best as you can make it. Could you use your graphing calculator to actually get the picture if you needed to? Yeah. Did I use my graphing calculator to do it? No. Some of you did. I saw Tamara show her group that's what she got. Is that okay? Absolutely. It's fine. I just used the transformation to do it. What do you think? Good. Then, on 13 through 16, it says match the function with the correct transformation. Explain your reasoning. So what happened to it? Did it get shifted? Did it not? Everything else. 17 through 24 says describe the transformation of the graph, then graph the function. So, let's see. Another group. Bryce. I called you the right name this time. Pick a number from 17 to 24. 24. Says g of x equals 1/2 x minus 1, the quantity squared. Okay. How many different pieces do I have in this problem? Savannah said 2 right away, and then somebody else over there, which I didn't see who said it, also said 2. Good. Savannah, what's one piece?
The half.
The half. Is the half being added or subtracted or multiplied? Multiplied is right. Inside or outside?
Outside.
Outside is correct. Outside means vertical. All right, so right away we're vertical. Now, because it's a half, Savannah, is that a stretch or a shrink? Shrink. Right. Sorry, I won't do that. Okay. It is a shrink. When that number is less than 1, but it's greater than 0, so those are your fraction pieces. Now be careful. If they would have said 5/2, that's not a shrink anymore, that's a stretch. Because the number is higher than 1. But she was right. It's a vertical shrink by 1/2. Savannah, thank you so much. Tamara, because you also said there was 2. What's the other piece that we haven't accounted for yet? Huh? The 1. What does the 1 do? Goes to the right 1. Very nicely done, you two. Great teamwork. So proud. Tear. So as I draw my graph, it's pretty straight. Okay. Do you want me to draw the parent in? No. Okay. So first thing I'm going to do is I'm going to move over to the right 1 space. Just like that. So I moved over right 1 space. Now as far as the half goes, when it's a vertical shrink, that's me going like this and pushing down on it. What's it going to happen? It's going to get wider. Some of you are wondering, how do I graph wider? You could put it in your graphing calculator to see, and that's okay. But the other thing you could do is you could plug in ordered pairs. If you really wanted to get it accurate, you could do that. But according to the graph on the calculator, you can also do that. How do you put in a half on your calculator? Put the half in parentheses, or could you put 0.5? The one thing that's tricky, if you had 1/3, 0.3 is not the same as 0.3 repeating. So you need to be careful. That's why I'd suggest doing it as a fraction. Does it look wider like this? Maybe not that wide, but wide like that, right? It's wider than the original. That's my point. So, did I describe the transformations? And did I sketch the graph? Awesome. Great job. Then, 27 to 30. Describe the transformation of the graph of the parent quadratic and then identify the vertex. The vertex, like I already mentioned, is that very bottom or top point. So we are going to identify what they are. The vertex in your equation is the h and the k. That's what it means. So, P, pick a number from 27 to 30. 29. 29 said f of x equals negative 2x squared plus 5. Now, Zach, not that, I'm just going to call him P and then use Zach so that way we know. P, did it say graph it?
Oh, no.
No. It says, tell me what happened, so describe the transformations, and then identify what the vertex is, the h and the k. So, let's see. Vitaly, do you know what one of the pieces happened? On the problem that we have. What's one of the pieces that got moved? The plus 5. What does a plus 5 do, Vitaly? Okay, can I let go so I can write that down? You asked me to hold on.
I got it. It just took that while.
They didn't see it. Okay, so Vitaly said up 5. Vitaly, nice job. You did great. It was up 5 because it was not in parentheses. Okay? Abby, what's another number? Careful. It is a negative 2, but remember, negative and the 2 have nothing to do with each other when we're writing the transformations. The 2. Is that inside or outside? Outside, because there's no grouping symbol. What's outside and the number 2 mean? Vertical stretch by 2. Thank you, Abby. Nice job. Zach, what's the last thing we haven't accounted for? The reflection over the x-axis. Nice job, you guys. So proud. And I'm not just being sarcastic this time. So, there's the description. We did great. Nice work. Now, the vertex has anything to do with the stretching or shrinking. It has nothing to do with the reflection. It has everything to do with, did you shift it up or down, and did you shift it left and right? So if we started at 0, 0, did we go left or right any? No. Did we go up or down any? Yeah. How far? In which way? 5 up. What ordered pair would I be at? 0, 5. The vertex is at 0, 5. That's what the vertex is. I label vertex by putting a capital V next to that point. That's how I usually do it. Okay? So we did not go left or right any. That would affect the x coordinate. We went up, so that affected the y coordinate. Does that make sense? Then, on 31 to 34, it says, write the rule for G described by the transformation of the graph of F, then identify the vertex. So, hope you're a loner. Pick a number between 31 to 34. 32. 32 says, here's your parent, f of x equals x squared. Now, it says that, but what's the parent going to be for every one of these? Quadratic or x squared. Every single one. We're not going to change that. Vertical shrink by a factor of 1/3. Vertical means inside or outside? Outside, multiplication or adding or subtracting? Multiplication. So how do I write 1/3? 1 over 3. Good. 1 over 3 x squared. I'm going to go step by step with them. Okay? Then it goes on to say, and a reflection in the y-axis. Where's y-axis reflection go? Parentheses. Tell me I don't have any. Yeah. Don't forget to put the deuce up there. What if you forget the squared up there? then you're not a quadratic anymore. So be very careful. Now, Chandler said that we have to go inside, or somebody, I think, right, Chandler, you said inside? And then you went on to say that if you don't have one, make one. So where do I put the negative at? Inside with, in front of the x. Then it goes on to say, which one am I on here? And then it goes right 3. How do I do right 3? And good job. You just wrote the equation. Now, the second half of that said, what is the vertex? I'm standing at 0, 0. Here I am. You told me to go to the right 3. 1, 2, 3. Do I go up or down any? No. Hunter's hoping not, because then I'd run into him, knock him over. So right now I went to the right 3. What order pair am I at?
3, 0.
3, 0. Done. There's my vertex. Awesome. Okay? No. Because if I would have went to the right 3 and then up 4, then my vertex would have been 3, 4. So that second number or the first number tells you right or left. Second number is how far did you go up or down. The right or left is the x, the up and down is the y. Awesome, good job, Tamara. So what do you guys think? Can you guys handle that?
Yeah.
All right, awesome. So on page 52 to 53, I think I had up there 3 to 39 multiples of 3. So for some of you that picked problems, and in particular I think it was Chandler and Bryce, you guys actually picked problems that were in the assignment. Yay! Okay? And if you didn't, boo! Whatever.